If I was to expand a set of brackets and I was to start with, let's say, x minus 1, x minus 2, and x minus 3. If I was to expand these brackets, I would start by expanding the first two set of brackets, so x minus 1 and x minus 2. And I would end up with x squared minus 3x plus 2. And then if I was to expand that answer with the final set of brackets of x minus 3, it would end up becoming x cubed, then it would be 3x squared, then it would be negative 3x squared again, then it would be plus 2x, then it would be negative 9x, and then it would be then it would be minus 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yep, so then I would collate those terms. So x cubed minus 6x squared minus 7x minus 6. So this would be my polynomial in standard form coming from this factored form. Now, if I was presented, so I'm presented with a polynomial with three sets of linear factors there, but let's say I was presented with a polynomial that was made up of a perfect cube. Now, a perfect cube, remembering a perfect square is where we have a plus b in brackets squared, and then we can remember that it expands out to be a squared plus 2ab plus b squared. Well, a perfect cube is the same thing in that you've got an a plus a b inside a set of brackets, but rather than being squared, you've got cubed. Now what happens then is that expanding that out, there's an actual formula. Now I could go and expand a plus b out like this, like we did before with our different linear factors. I could go and expand that out. So I could actually go and do that, and I would end up with something like this: a squared. So I'm going to expand the first two set of brackets, a squared, and then I'd end up with a times by b plus a times by b, and then I'd end up with another a times by b, and then I'd end up with b squared in a set of brackets multiplied by a times b. And if I collected the like terms here, I'd end up with a squared plus 2ab plus b squared, as well as still multiplied by a plus b. And then if I was to multiply the three terms in here with the two terms here, I'd end up with a cubed, so that would be a cubed, and 2ab times, let's say a as well, it would be 2 times a squared times b, and b squared times by a would be b, let's put a in front, and it'd be a times by b squared. And then if I was to multiply a squared times by b, it would be a squared times by b plus 2ab times by b, which would give 2ab squared, plus b squared times by b, which would give b cubed. Now then if I was to collect the terms, I'd end up with 2a squared b plus a squared b, which gives me 3. So collecting these two terms, I would end up with a cubed plus 3a squared b plus collecting these two terms, I'd end up with 3ab squared, and then I'll carry the b cubed down, so I end up with b to the power of 3, and I finally end up with my answer here. So a plus b cubed ends up with, finally gets me a cubed plus 3a squared b plus 3ab squared plus b cubed. Now notice that the power of a decreases as I go from left to right, and the power of b decreases as I go from right to left. The coefficient is always 3 and 3 in the middle, and 1 and 1 on the outside. But that's how you can get from a perfect cube into its expanded form. if I didn't want to go through this whole process that I've just gone through then, and I know that I always end up with a cubed plus 3a squared b plus 3ab squared plus b cubed, if I know that, and I should be able to remember that, then I can quickly go straight from a plus b cubed to a cubed plus 3a squared b, because I'm decreasing the power of a as I go from left to right, plus 3ab squared plus b cubed, because I'm decreasing the power of b as I go from right to left. So the power of b in this term is 0, which means b to the power of 0 is equal to 1, so it's just 1 times a cubed. So I can actually, if I see a factorized cubic, such as, let's say, x squared plus 3 in brackets to the power of 3, then I can say that I have x to the power of, well, it'll be x squared in brackets to the power of 3 plus 3 times by x squared in the brackets to the power of 2 plus, times by 3 plus 3 times by a, which is x squared, multiplied by b squared, which is 3 squared, which is 9, multiplied by 9, plus 3 cubed, so a cubed, which is 3 cubed. So I end up with 27. And then I can I can actually evaluate this out even further. So I can end up with 2 to the power of 3 be x to the power of 8. And then I would have 3 times by 3 is 9, and x squared 2 to the power of 2 is 4, so I would end up with 9x to the power of 4, and then I would end up with 3 times by 9 is 27, so, and that's times by x squared, so 27x squared plus 27. So if I was to expand these out, I would end up with x to the power of 8, 9x to the power of 4 plus 27x to the power of 2 plus 27. And I can also do that for cubes where it's a perfect cube, but there's a minus sign in this position here. So if I had, let's pick x minus 3 without the x squared, just to make life a little bit easier for myself. It's going to be x minus 3 to the power of 3. So rather than having a plus there and a plus there, it's the same formula, but now there's a minus in this position and a minus in this position. So I'd end up with x cubed minus 3 multiplied by x squared times by 3 plus 3 times by x multiplied by 3 squared plus 3 cubed. Sorry, that one's minus. So, and then I would evaluate that further, and I'd get x cubed minus 3 times 3 is 9, so minus 9x squared plus 3 times 3 squared is 3 times 9 is 27, so I'd end up with 27x minus 3 cubed, which is also 27. So pretty similar. So this here, it's the expanding of this perfect cube here is very similar, except there's a minus sign there and there's a minus sign there.